The Apollo program ran from 1961 to 1972. During this time, humans landed on the moon 6 times, with the historic moment many of us are familiar with being the first of these, during the Apollo 11 mission, when astronauts Neil Armstrong and Buzz Aldrin were the first humans ever to land on the moon. It was during this landing that we were brought this unforgettable moment.
It's one small step for man, one giant leap for mankind.
Things would not end there either. Following this, there would be 5 other missions to successfully land humans on the moon. These are Apollos 12, 14, 15, 16, and 17. The last astronauts during this time to touch down on the moon were Eugene Cernan and Harrison H. Schmitt. Unfortunately, as all things do, the program came to an end, being cancelled mostly due to budget cuts. As one might expect, the cost of getting humans safely to the moon and back is ironically astronomical. As of this recording, 52 years have passed since the end of the Apollo program, and while we have not yet set foot back on the moon, there is a new program in place to take up the mantle. This is known as the Artemis Program, named for the Greek goddess of the moon, and the twin sister of Apollo. This program is currently split up into 4 parts, though I have heard there are more planned for the future. Let us start off, though, with the first of these, which is Artemis 1. Artemis 1 is currently the only completed mission from the program. It launched on November 16th, 2022. The Orion spacecraft was lifted into space on top of the SLS rocket, also known as the Space Launch System. This was an unmanned mission meant to test the effectiveness of the current equipment and gauge what may have happened to humans had they been part of it. It was a flyby mission that lasted 25 days and traveled a total of 1.4 million miles. And on December 11th, 2022, it re-entered the Earth's atmosphere at 24,581 miles per hour, splashing down in the Pacific Ocean, west of Baja California. 3 pieces of equipment were tested during this time: the Orion spacecraft itself, the Space Launch System, and the Exploration Ground Systems at Kennedy Space Center. There were also a number of sensors and test dummies aboard Orion that could help gather data on how humans might be affected while inside the spacecraft. During the mission, the Orion spacecraft performed 2 lunar flybys, coming within 80 miles of the lunar surface. At its furthest distance during the mission, Orion had traveled nearly 270,000 miles away from Earth. For comparison, this is over 1,000 times farther than where the ISS orbits. During the flight test, Orion stayed in space longer than any spacecraft designed for astronauts has done without the need to dock at a space station. Orion also surpassed the record distance traveled by spacecraft designed to carry humans, the record that was first set by Apollo 13. After it completed its flybys, the Orion spacecraft returned to Earth. During re-entry, it endured temperatures about half as hot as the surface of the Sun, around 5,000 degrees Fahrenheit. Within 20 minutes, through basically aerobraking, Orion slowed down from the nearly 25,000 miles per hour I mentioned earlier to only 20, to go into its parachute-assisted splashdown. After this, recovery teams worked to secure Orion, bringing it on its journey home, where it was and will be studied by various specialists in the field. The results of this could likely be covered in its own video. For today, though, let us continue and look towards future missions, the next one being Artemis 2. This second mission will see astronauts included, making it the first crewed mission of the Artemis program. The astronauts aboard Orion will confirm all of the spacecraft's systems operate as designed, with crew aboard and in the actual environment of deep space. The unique mission profile for Artemis 2 will build upon the uncrewed Artemis 1 flight test by demonstrating a broad range of SLS and Orion capabilities that will be needed during future deep space missions. This includes things such as proving Orion's critical life support systems are ready to sustain humans in space on the longer duration missions, and allow the crew to practice operations that will be essential to the success of Artemis 3, which will be the follow-up mission to this one. Artemis 2 will leave Earth with a crew of 4 astronauts from the Kennedy Space Center in Florida. It will launch on the Block 1 configuration of the SLS rocket, and once up there, Orion will then perform multiple maneuvers to raise its orbit around Earth and eventually place the crew on a lunar-free return trajectory. This means that upon return, Earth's gravity will naturally pull Orion back home after it flies by the moon. During this time, Orion will see itself in 2 different orbits around planet Earth, before then heading off to the moon. This will allow the team to ensure the spacecraft's systems are functioning as expected while still relatively close to Earth. The first orbit will be elliptical and will range from 115 up to 1,400 miles above Earth, and it will last a little over 90 minutes. Then, after this, the spacecraft will lift itself into a high Earth orbit, also elliptical, and this one will range from the 115 miles above Earth, but now all the way up to 46,000 miles above Earth. For some perspective, the ISS flies nearly a circular orbit about 250 miles above Earth. After the needed checks are completed during these 2 orbits, the crew will push off towards the moon while also taking manual control of Orion. This to help demonstrate and gather data on more of its capabilities. This will also include piloting Orion's flight path and orientation. So they're going to, instead of testing ground control, now they're going to be testing manual control for Orion. This will also include a maneuvering test where the astronauts will use Orion's onboard cameras and view from its windows to line it up with one of its propulsion stages, known as the Interim Cryogenic Propulsion Stage, or ICPS for short, along with approaching and backing away from it. This will provide performance data and operational experience that cannot easily be gained while on the ground. Following this demonstration, the crew will then turn control of Orion back to mission controllers at Johnson, and then they will spend the remainder of orbit verifying the system's performance in the deep space environment. They will remove the suit that they launch in, known as the Orion Crew Survival System, and spend the remainder of the in-space mission in regular clothing, like what I have right here, only donning the suit again when it comes time to re-enter Earth's atmosphere. While in space, they will continue to check life support systems, communication systems, and control systems, some of which we mentioned earlier, all to ensure that the spacecraft is ready for both the lunar flyby on this mission and for use in future missions. Artemis 2 will last between 8 to 10 days and will reach a maximum distance of around 230,000 miles, and will ultimately lead into the next mission, which, if successful, will be historic in a number of ways, not only returning humans to landing on the moon, but also including both male and female astronauts. The next mission, of course, is aptly named Artemis 3. We have touched on the launch and travel aspects of Artemis when covering the first and second missions. For 3, upon arriving at the moon, the Orion spacecraft will enter an NRHO orbit, which stands for Near Rectilinear Halo Orbit. Selected from hundreds of potential orbits, NASA chose this one because of its benefits for long-term Artemis goals. It will provide near constant communications with Earth and access to sites all over the moon. Also, because it is gravitationally balanced between Earth and the moon, this orbit will maximize fuel efficiency. On future missions, NASA and its partners will assemble the Gateway Lunar Space Station in an NRHO orbit to serve as a hub for future Artemis missions. We will touch more on this one later in the video. NASA has selected SpaceX to provide the human landing system that will transport Artemis 3 astronauts from the Orion in lunar orbit down to the surface of the moon, and of course back again. SpaceX plans to use a unique concept of operations to increase the overall efficiency of their lander, probably not too dissimilar from how they created landing rockets here on Earth. After performing a series of tests, SpaceX will fly at least one uncrewed demo mission that lands Starship on the lunar surface, and then sees it taking back off again. And when Starship has met all of NASA's requirements and high standards for crew safety, it will be ready for its first Artemis mission. NASA has its sights set on locations around the South Pole for the Artemis era of human lunar exploration. Extreme, contrasting conditions make it a challenging location for humans to land, live, and work. But the region's unique characteristics hold promise for unprecedented deep space scientific discoveries. Using advanced technology, which includes autonomous systems, the crew inside of Starship will land at a carefully selected site within a 100-meter radius. After touchdown, the crew will check to ensure that all systems are ready for their lunar surface stay. They will rest, eat, and recharge in preparation for the first full day of exploration. During their time on the moon, the astronauts will do scientific work inside of Starship and conduct a series of moonwalks, exiting Starship to explore the surface. During their moonwalks, the astronauts will take pictures and video, survey geology, retrieve samples, and collect other data to meet specific scientific objectives. The view we will get here from the lunar South Pole region will look very different from the photos taken on Apollo missions, which happened in the moon's equatorial region. The sun will hover just above the horizon, casting long, dark shadows across the terrain. The crew will be equipped with headlamps and other navigational tools to help with exploring these more dark areas. The information gathered here will help increase our understanding of the mysterious South Pole region, the moon in general, and even our solar system. Once this work is completed, the crew will return to the Orion spacecraft via Starship, and, over a handful of days, transport the samples between the two before using Orion to head back to planet Earth. Should this mission be successful, and I truly hope that it will, we will not only have successfully set foot back on the moon, but accomplished many other really cool goals as well. However, to me, this is not the end, and if anything, it feels more like the beginning. All of this will come to a head in the last currently planned mission, which is Artemis 4. It will also truly pave the way for future exploration of space, other planets, and our solar system. And you know what? I would say even beyond just that. This brings us to the Artemis 4 mission, which aims to create a lunar space station known as Gateway. This station will be built with international and commercial partnerships and will serve a multitude of functions, which include providing docking ports for visiting spacecraft, providing space for crew to both work and live, and to help prepare for future lunar surface missions. It will also come equipped with instruments for scientific investigations to study things like heliophysics, human health when in space, and life sciences, among other areas. The orbit for Gateway, which we mentioned earlier, will be an oval shape and will pass over both the north and south pole areas of the moon. This will help it provide unparalleled opportunities for both science and access to the lunar surface. Being elliptical, the orbit provides more major benefits as well, such as providing surface access from low lunar orbit, along with fuel efficiency from distant retrograde orbit, while at the same time offering unique views of the Earth, Moon, Sun, and deep space for scientific study. Gateway is already being assembled on the ground as we speak, with engineers planning on connecting its first two modules, the Power and Propulsion Element, PPE, which was built by Maxar, and the Habitation and Logistics Outpost, or HALO, which was built by Northrop Grumman, all in preparation for when the time of launch comes. Upon arrival, Artemis 4 will consist of moonwalks performed by astronauts, again with the help of Starship. But for this video, I wanted to cover a bit about Gateway and the orbit it will be in. What I'm thinking is once we get closer to each of these missions actually being prepped for and about to be launched, I will cover them more in depth with individual videos. While it has been longer than many of our lifetimes, at least mine anyway, since a human last set foot on the moon, this program really does get me excited for the future. A future where during most of our lifetimes, we not only get to witness humans once again stepping on the moon, but advancements far beyond what Apollo could ever have accomplished. And come on, who would not think that a moon base is awesome? I hope you've learned something today and are now as excited as I am for space travel, investigating the moon, and just our future in space in general. And of course, let's all step outside tonight and look towards the stars.